Let's take a look at some application problems or modeling with systems of equations. So here, Jonathan has 9 bills in his wallet that are either $5 bills or $10 bills. Fill out the following table to see the dependence of the two variables and how they determine how much money Jonathan has. So when they talk about looking at the dependence, we're looking at the relationship between the two. So if he has 0 5s, then he would have 9 10s, because he has 9 bills altogether, and the amount of money would be $90. If he has 1 5, then he could only have 8 10s, and the amount of money would be $5 from the 5, and then 80 from the 10s, or a total of $85. If he has 2 5s, he can have 7 10s, so we would have 10 and 70, or $80. If he had 3 5s, he could have 6 10s, so it'd be 15 and 60, which is $75. So as the number of 5s increases, the number of 10s decreases. And when the number of 10s decreases, the amount of money he has also decreases, because 10 is worth more than 5. If F represents the number of $5 bills and T represents the number of $10 bills, what does the following expression calculate? Explain. So this goes back to when we practiced interpreting expressions. So 5F plus 10T, this is the total amount of money Jonathan has in his wallet. Because it takes the number of $5 bills and multiplies it by the value of a $5 bill, and the number of $10 bills and multiplies it by 10, which is what I did to figure out the amount of money in our table. Now here, we know that Jonathan has a total of $55. So we're going to set up a system of equations to determine how many of each bill he has. So I know that 5F plus 10T, and what I do is I curve the T at the bottom so you know it's not the plus sign. We know that has to equal $55. But we also know he has a total of 9 bills, which means that the number of $5 bills and the number of $10 bills has to equal 9. So this is my system. Okay. A lot of times a bracket is used to indicate that it's a system. They're not always the easiest to draw, so just practice. You'll see them a lot going forward in mathematics. So now I need to solve, and I want to try to figure out then how many bills does he have. So I'm going to take my second equation and multiply by 5. And then I have my first equation here. Because they're the same, I subtract. So negative 5t equals negative 10. So t is equal to 2, which means that he would have 2 $10 bills. So now let's see, does it work? So now I'm going to actually use my second equation because it's easier to use. So here, if t is 2, then f must be 7. And now I'm going to check. Does it work? So 5 times 7 plus 10 times 2 is 35 plus 20. It does work. So Jonathan has 7 $5 bills and 2 $10 bills. When you're talking about number like $10 bills, unless you write out the 5 and the 10, that's kind of how you would write it. All right, now this next one is still looking at Jonathan, but now instead of having 5s and 10s, we actually know that he has 5s and 20s. He has 7 bills total, and a total of $120. So now, again, let's go back in, let's set up the system. So now I have 5s and 20s. So now my 5s and 20s need to be 7. And when I take 5 times f plus 20 times t, that's giving me 120. And I'm going to tell you what those are. So let f equal the number of 5s, and let t equal the number of 20s. So now I have a new system, and I'm going to solve. So again, I'm just going to multiply it by 5. Oh, sorry, I was moving too quickly. My brain moved too quickly for my hand that time. So now I have my new equation. So I have 5f plus 20t equals 120. And 5f plus 5t equals 35. Same sign, so I subtract. 15t is going to be equal to 85, and so t is equal I feel like I did something wrong. We know he has 7 bills, because I'm not getting an exact answer. I'm getting 5 2/3, which is impossible. You can't have 2/3 of a bill. $120. F plus T equals 7. 5T, 5F. 7 times 5 is 35. 120 minus 35 is 85. 20 minus 5 is 15. Oh, do we have true information? No, because you can't have 2/3 of a bill. So, the information given cannot be true because you cannot have 2/3 of a bill, right? It wouldn't count as 2/3 of the money. All right, let's look at another one. So here we're going to be looking at how we can determine unit prices. Samantha went to a concession stand and bought 3 pretzels and 4 sodas and paid a total of $11.25 for them. Raza went to the same stand and bought 5 pretzels and 2 sodas and paid a total of $8.25. Could pretzels have cost $1.75 each and sodas $1.50 each? How can you evaluate based on the information given? So with the information we were given, I can multiply. So I can do 3 pretzels times $1.75, which is $5.25, and 4 sodas times $1.50, which is 6, and the total is $11.25. So that one works. And then 5 pretzels times $1.75 is $8.75, and then 2 sodas is 3, which is $11.75. So that does not work. This cannot be the price of each one, right? Because this is not correct. So those are not the right prices. So can we figure it out? Can we write a system so we can figure out what the unit price would be? So X is the cost for a pretzel, and Y is the cost for 1 soda. So I know that 3 times X and 4 times Y has to equal $11.25. I also know that 5 times X and 2 times Y has to equal $8.25. So now I can solve my system. I'm going to multiply my second equation times 2. and solve. So this is telling me actually that X is 75, which means that the cost of one pretzel is 75 cents. So now I'm going to solve for Y. Okay, so according to this, pretzels cost 75 cents and sodas cost $2.25. So let's check and see if it works for our second equation here. So 5 times 75 cents is $3.75, and 2 times $2.25 is $4.50, and if I add those together, I do get $8.25. So this is the cost. If Leah went to the same concession stand and bought 2 sodas, how many pretzels would she need to buy so that she spent the same amount on both? So I want to have 2y equal sorry, I'm not going to do that. I'm going to do it by the cost. So 2 sodas, so 2 times 2.25, right? Or you could do 225y must equal 75 cents times x. I know I want to use the value here for 2 for my y value. So I get so Leah would need to buy 6 pretzels. Okay. And this last one is looking at rectangles. So we want to be able to do this with rectangles as well. So here, I like to draw the picture. So I know I have a rectangle, and I have my length and my width. My perimeter is 204. So perimeter is 2 times the length plus 2 times the width. Okay. And I know that is 204. The length is 6 feet longer than twice the width. So the length is 6 feet longer than twice the width. So now I've written my system already, and now I'm going to use it to solve. So I'm actually not going to use elimination. I'm going to use substitution because I have a variable isolated. So I'm going to substitute here. And solve. Come over here so I have more room. So 6W Okay, so according to this, my width should be 32 and my length 70. So now I'm going to check. using my perimeter. So if I have 2 times 70 plus 2 times 32, 140 plus 64 does in fact work. So the length of the rectangle is 70 feet, and the width is 32 feet. Okay.